In this example, we're shown a function. You can see on the graph that the function has the equation y equals the square root of x minus 1. The first thing we're asked to do is express the rule as a function of y. So currently we have y equals the square root of x minus 1. So what we're going to do is square both sides. Y squared will then equal x minus 1, then add 1 to both sides. That will give us x equals y squared plus 1. We now have expressed a rule where it is a function of y, not a function of x. So now we're going to go on to do part B. Looking at the graph, you can see the shaded region is not underneath the graph of y equals the square root of x minus 1. And that is why this has got us to put this into a function of y as opposed to a function of x. Using a similar process, what we can now say then is the area underneath the curve. Now the curve, the blue line, we have just worked out we can express as x equals y squared plus 1. So instead of our terminals being in terms of x, they're going to be in terms of y. So we have y equals 0 and y equals 2. So it's going to be the integral between 0 and 2, but they are for y. Our y function we've just found is y squared plus 1. So we're going to anti-derive with respect to y. Anti-differentiating this expression, we get y cubed on 3 plus y between 0 and 2. Now we're ready to substitute in our terminal values. Substituting in 2 for y, we get 2 cubed on 3 plus 2 minus, substituting 0 into y cubed on 3, we get 0. Substitute in 0 for y, we get 0. So we're going to have 8 on 3 plus 2. 8 on 3 plus 2 is 4 2/3 square units. That is our exact answer. Alternatively, though, we could have done this question in another way. What we could have done was looked at the area we had there. We know when y equals 2, x was equal to 5. So we could have said the area of the rectangle, which would be 5 units by 2 units, 5 times 2, minus the area under the curve we had, which would have been the area from 1 to 5, which would be the integral from 1 to 5 of the square root of x minus 1 dx. Equally, that would have given you the answer. We were guided the way we went by the fact of part A getting us to express the rule as a function of y. If you look at our calculator displays, you will see that for part A, I typed in solve y equals the square root of x minus 1 for x, and you see it gave us x equals y squared plus 1 for y bigger or equal to 0, which matches up with what we got for part A. We then asked the calculator to evaluate the integral from 0 to 2 of y squared plus 1 dy, and we've got 14 on 3, which is 4 2/3 square units.